Hi everyone, welcome back to the channel. Today we'll be diving deep into decision tree algorithm, especially the CART method using scikit-learn. We'll explore how it works, how it uses Gini impurity for classification, and how to visualize the decision tree. Let's get started. First of all, it is a decision tree? A decision tree is a supervised machine learning algorithm used for classification and regression tasks. It works by splitting the data into subsets based on the feature that result in the best possible split. And this splitting continue recursively to form a tree-like structure. In classification, the leaves represent the class label and the branches represent decision rule based on the features. Next, what is the CRT? So it stands for classification and regression tree. In classification problem, the goal is to build a tree where each node represents a decision based on a feature, and each leaf node represent correspond to a class label. The algorithm uses the criteria to determine the best split at each node. So in our cases, we'll focus on Gini impurity, which is commonly used for classification tasks. So Gini impurity is calculated as this formula where Pi represent it is the proportion of a samples in the class I and C is the number of the classes. A Gini impurity of 0 means the class node is pure, meaning all samples belong to a single class. Now let's take the example of famous iris dataset as an example, and it contains information about flowers. The dataset has 150 samples from 3 species of iris flower, and we'll use this dataset to build our decision tree. So now let's import our libraries and deload the dataset. Next, we'll split the data into train and test data. And let's import the decision tree classifier from scikit-learn and train the model using our training data. So here I'm importing the decision tree classifier and fitting the model for with X-train and Y-train dataset. As you can see here, we are specifying the Gini criterion, which is the default of the scikit-learn decision tree classifier. We train the model on the training data and fit it with the feature matrix X-train, and the target vector is Y-train. Now, once the model is trained, we can visualize the decision tree to see how it's making a decision. So in this, the plot tree function from scikit-learn will display the decision tree, and you can see the features we are used for each split, the Gini impurity for each node, and the glass distribution at the each leaf. So let me run this. And as you can see, this is a very beautiful decision tree where we have each feature is split right using the Gini impurity. As you can see, the Gini impurity at each level, and all the distribution, the classes distributed at the each leaf level. Now that the tree is trained, let's use it to make prediction on the test data. So if I will call predict function, and we'll use the predict method to make the prediction on the test and then calculate the model accuracy using the accuracy score. So if I run this, here accuracy is 1 because this is a very small data set and it's predict the all the data correctly. So that's why it's almost perfect. But in the real time, it will not be. So at each decision node in the tree, the algorithm chooses the features that minimize the Gini impurity. And let's break it down with some example. So for instance, if a node had 50% of a sample of a class A and 50% of class B, the Gini impurity would be something called 0.5. This means the node is relatively impure, and the tree will continue splitting until it reaches a node with the Gini impurity class to 0, where the samples are pure. So if we go up, as you can see, the Gini impurity at the end is 0. So means it cannot be further split. So to wrap up, today we learned about the decision tree algorithm using CRT method, how it used Gini impurity to decide the best split, and how to implement it using the scikit-learn. We also visualized the decision tree, as you can see, and evaluated performance on the iris dataset. So decision tree are powerful models, but they can overfit. So technique like pruning and using a sample method like random forest can be helpful. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe. See you in the next one. Thank you.